It's wonderful to see folks coming in to our Zoom room. We're just going to wait till everyone arrives and then we'll get started. Welcome, everyone. Open Space Institute and the Forest Carbon Data Partnership is really pleased to welcome you to our second field briefing on forest carbon data and tools. We're here to help ensure the field has access to the latest data and tools to advance land conservation as a climate solution. I'm so pleased to see the interest in gathering together to ensure we have the best data and tools. Each of your work is going to be more important than ever over the coming years. And it's really encouraging to be together and look at how we can do this work most effectively. We have a great set of partners gathered to speak at this program. Dr. Christopher Williams from Clark University will speak about the new forest carbon data. Joe Fargione and Dan Majorca of TNC, the Nature Conservancy, will cover design of new tools. And Kelly Watkinson and Taj Shotland of Land Trust Alliance and Trust for Public Land will talk about how we can access the data and then how you all can find additional support to utilize it. But before we dive in, I'm really pleased to turn it over to Eric Kulisade, Open Space Institute's President and CEO, to welcome you all.
Thank you, Abby. Thanks for inviting me to be here today. While there's a lot we don't know about the future these days, we do know that land conservation and nature-based solutions are perhaps the best and most effective way to advance climate change across this political spectrum. Natural climate solutions are actions that restore, protect, or improve ecosystems and at the same time pull carbon out of the atmosphere. In a 2024 poll by U.S. Nature for Climate, protecting land for fish and wildlife has the greatest support of any natural climate solutions, with 80% support from Republicans and independents and 92% approval from Democrats. And while we know renewable energy is a critical part of the solution to climate change, natural climate solutions ensure a livable climate future, providing a diversity of values to our society. OSI is proud to be leading on this topic and will remain invested in this work going forward. Through our Outdoor America campaign, we will continue to protect funding for LWCF and the myriad programs it supports. Through science and mapping, we will ensure state agencies and land conservation groups have the best data and science to advance their climate goals. Through our land protection funds, we are driving private philanthropy to support the conservation field. And through the data and science, which you'll hear much more about today. OSI is so pleased to bring together leading NGOs to elevate land protection as a climate solution. The Forest Carbon Data Partnership gathers the science, policy, and practical know-how to ensure a comprehensive vision and that the job gets done.
Thank you, Eric. As you all likely know, and why you're here, forests are critical to meeting all of our climate goals. They store 30 years worth of carbon emissions, of US carbon emissions, represented by the radius of this big circle on the right. And they sequester 12% of US annual emissions, represented by the dot on the left. This image illustrates why protecting our existing forest carbon is so important. This is often called carbon defense, and it's a critical piece of our climate solutions. In fact, forest protection has the potential to contribute broadly to natural climate solution pathways. Avoided conversion is one of the key ways that land protection can contribute, reducing emissions through avoiding the loss of forest to development. Land protection maintains the carbon sink. The loss of forest land to development is actually the leading cause of declining sequestration rates in many states, especially in the eastern United States. And through improved forest management, that carbon sink can be improved and increased. And when land moves into conservation ownership, there is this opportunity to ensure sustainable forest management into the future. So this is why the Forest Carbon Data Partnership is so excited to launch the new 2020 Forest Carbon Dataset developed by Clark University. The data and tools are critical to ensuring decision makers can protect high carbon biodiverse forests that are at risk of conversion. The dark greens here are our nation's high carbon forests, and I'm apologizing to anyone from the outlying states and territories which are not included in this data set. The blues are average, the reds in our colder, drier forests are lower carbon forests, but remain important for many reasons and have a critical ecological role. And I want to draw your attention to the data units there on the bottom right. This data launch, we moved from tons of carbon to tons of CO2 equivalents. And we did that to support the field in understanding the values of forest conservation in addressing greenhouse gas emissions, which are typically reported in CO2 or CO2 equivalents. Units are tricky and they can trip us all up. So take a look at that little note in the bottom right about how to make the conversion from tons of carbon to CO2 equivalents. One of the powerful things about this data is it includes estimates of future carbon stores based on growth curves for each forest type. We're now looking at estimated forest carbon stores for 2050. This helps us understand not just where the carbon is today, but where we can best support ongoing sequestration. So I'll just do a little toggle between those two data again. You can see the dark greens increasing, especially across our wood basket in the southeast. For example, we can look at the impact of some of the powerful federal programs that are advancing forest protection and understand their forest carbon benefits. The nearly 500 projects supported by the U.S. Forest Legacy Program protect 2.9 million acres in the continental U.S. They store 775 million metric tons of CO2 and annually sequester 3.2 million metric tons. That's the equivalent of 101 million homes off the grid per year, and the sequestration is equivalent to about a little less than 500,000 homes off the grid. So we can start to attach real numbers to the values of these programs. We can also look at our forest legacy areas protecting and allowing for conservation projects in our high carbon areas that might be at risk of conversion. This green layer is an overlay on top of the forest carbon data showing the existing forest legacy areas. These forest legacy areas are up for review as part of the 2025 update to the forest action plans. Just one way that the data can advance decision making. Data and science have the power to drive impact. This partnership is here to help the conservation community understand how everyone can pick up an oar and really ensure we're moving more swiftly towards shared goals. So I will be watching the chat for questions throughout this session and helping to frame our panel conversation, which will happen during the second half of our time together. For now, I'm really pleased to turn it over to Dr. Christopher Williams, the data author and really thoughtful leader in this field.
Thank you, Abby. One moment while I get organized. Okay. So it's a pleasure to be with all of you. I'm Chris Williams at Clark University in Geography and Earth System Science. I've been really delighted to collaborate with all of the members on today's call for several years now in bringing what we developed through early NASA funding, as well as some of our own funding from Clark University, to be able to bring an update to this framework that we call the NFCMS, the National Forest Carbon Monitoring System, which is a wall-to-wall 30-meter mapping of forest carbon, as you've just seen displayed. And thanks to some new funding and a collaboration here with these forest carbon group partners, we've been able to bring you this update, and hopefully it's of value for many. So I'll tell you a little bit about our update. And I'm going to follow through with about 7 different questions. The first is, why is it important to update these data in the first place? And it's clear that up-to-date forest carbon is important for a lot of reasons. It's essential for supporting conservation organizations and government agencies in understanding the importance of forests as part of emissions reduction strategies, and in directing conservation to places where it can be most effective at reaching and supporting climate goals. The NFCMS provides a detailed intelligence perception or perspective on the climate benefits of avoiding deforestation, of maintaining the forest carbon sink, and of climate smart management. And quantitative assessments such as this of forest carbon are needed to inform climate policy for state agencies, for conservation organizations, or for land trusts and their land protection priorities. It also can aid with a range of use case scenarios as illustrated here in the boxes. So this forest carbon data update brings us to the year 2020. What we've done is we've removed areas of forest that saw conversion to non-forest with very careful analysis of land cover time series. We also decreased the biomass in places that have seen a recent cut. We add areas that have seen recent forest gain or infilling of low forest cover areas. We grow standing carbon stock up to the near present, and we update the expected sequestration not only to 2050, but also to 2070, another time frame of relevance with a grow-only scenario. So thanks to this partnership and the new funding, we were able to bring a kind of fresh new perspective on where things stand in our forests today. And I'm just going to give you a very quick illustration and example of what this looks like and why this was important. Take, for example, this recent cutover. This is from Maine. It happens to be sort of a postage stamp zoom of a place that was cut in 2014. Not all of the trees were removed, but there was a decrease in tree density. And our previous data set in 2010 wouldn't have seen this. It had relatively high forest biomass, as shown here. But in 2010, bringing us up to 2020, we see that these relatively high values are now much lower in the data update. So seeing our shift to 2020, here we now notice that we've gone down in forest carbon stocks. It still remains forested, but the current biomass stock is much lower than what we had seen in the previous data set. I'll just go back one more time and illustrate the big change. So that's just one example of what this data set update allows us to do. Another thing that we need to think about is just, well, sometimes people get tripped up with language such as carbon stocks, carbon sequestration, and even carbon storage. When we talk about carbon stocks, we're referring to the amount of carbon that's in a forested ecosystem at a moment in time, that's held in a range of different reservoirs, such as live woody biomass and soil carbon or coarse woody debris. By contrast, carbon sequestration is this process of capturing atmospheric carbon dioxide and storing it, fixing it and storing it in the components of the forest ecosystem. So it becomes a new growth or an increment in the forest carbon stocks that importantly has to be stored for the long term, and so that it can actually be a lasting net sequestration. And sometimes it's helpful to provide sort of a comparison of the magnitudes. The current carbon stocks held in forests tend to be a lot larger than the year-by-year gains. So for example, forest carbon stock might range from 40 to about, well, over 1,000 metric tons of carbon dioxide equivalent per acre. By comparison, carbon sequestration will range from 0 to up to about 7 metric tons of CO2e per acre per year. And this just underscores just how important the current carbon stocks are as part of our protection opportunity. Another thing we're sometimes asked is just, well, which carbon pools, which carbon stocks are included in our data set? The NFCMS tracks forest carbon in a whole suite, as I said, of live and dead carbon pools, including above ground wood, in leaves of living trees, coarse weedy debris and snags after fires, litter, below ground in the living root systems, the organic and mineral soil, and even the microbial community. We provide estimates of all of those, and we roll it up into a total ecosystem carbon that includes the carbon in all of those pools. Quantifying the carbon in all the pools is possible because we combine the strength of inventory, forest inventory data to train a carbon cycle model. We constrain the carbon cycle model with the inventory data, incorporate a whole bunch of different carbon pools from that inventory data, and force the model to go through those data. And then we capture a bunch of things that are harder to measure through a mass balance in the model. And comparison to forest inventory data shows that we have generally good agreement across the suite of carbon pools and in the total ecosystem. So we have pretty good confidence in the framework on the whole. Sometimes we're also asked, well, why is carbon so variable from place to place? And some of this might be obvious. But there are a lot of factors that can cause carbon to be high in one place and low in another. Sometimes it's recent disturbances, and you see the imprint of recent disturbances in the kind of image time series in the backdrop here. This taken from our previous version of the NFCMS. It now, of course, is updated to 2020. But in these couple of cutouts, you can see how the landscape is constantly changing, how the magnitude of carbon flux and also the biomass in those locations can be highly dynamic. Recent disturbances is one of the major drivers of that variation in space and time. Another one, you can also see gradients in climate and soils, as well as forest types, and even topography. And the imprint of those are embedded in the way we map because of a whole suite of attributes of the landscape that we incorporate in our methodology. And sometimes, if you're really zooming in on any one track, you'll find that partial forest cover, that is, at a forest edge, for example, or maybe with a park or a lawn, park with a lawn that backs up to forest. Some of those areas may have only a lower potential maximum biomass because not the whole pixel is covered, not the full quarter acre that we map. Taken together, these factors lead to pretty large-scale variation in patterns of forest carbon at the continental scale, with hot spots of high and low, as we saw in the map earlier, principally due to climate, but then within any smaller region, it'll be things like forest type and soils, maybe microclimate, certainly fertility and hydrology, and then recent management and natural disturbance patterns. And we try to roll all of that up into our relatively high resolution mapping. So how well do we do when we compare to other sources of information? A bunch of our studies have provided detailed comparisons at state and regional levels to U.S. Forest Service reports of forest carbon stocks and fluxes. All these comparisons show pretty favorable agreement. We also have compared to other forest biomass and forest carbon flux estimates. And again, we find very strong agreement. We compare those again at state, regional, or maybe by forest type levels, but sometimes we zoom in and look at the exact spatial distribution. And there we find, again, pretty good agreement all the way down to about a 1 kilometer scale. And going any finer than 1 kilometer, then it starts to depend pretty heavily on whether or not the data set incorporated a detailed spatial mapping of whether or not forests have seen severe disturbance lately, which is something that we incorporate, but not all data sets are able to incorporate it in the same way. Independent evaluations performed not by us have also been favorable. One of them was a plot level evaluation of above ground biomass that found about a 6% error rate in 12 forest carbon projects in the mid-Atlantic, with a lower error rate than NCX, the former Sylvia Terra. And another independent evaluation found only a 2% error rate for carbon projects in the Central Appalachians. So we encourage additional analysis performed by either us or others. We often learn the most when other people tell us how things compare from their studies. And so we certainly recognize and appreciate those efforts. So we think additional testing of this new 2020 data is still warranted and would be highly valuable, particularly with field measured plot data, but also maybe some remotely sensed forest carbon estimates. So as for the assumptions of the NFCMS framework, there are many, and many of them are listed here. It turns out that mapping forest carbon dynamics at a quarter acre or 30-meter resolution across the whole country in a way that addresses forest type variation, disturbance history, site productivity class, and that harmonizes the strengths of remote sensing of different kinds, as well as forest inventory data. Is a pretty complicated business, and it requires some simplifying assumptions. The guidance document that we provide, as well as other related publications, detail those assumptions, and we encourage data users to think about the implications of them, as well as to ask questions of us when they aren't sure about what has gone into it. So we encourage that as always. And then another question we've been asked to respond to is just, well, what might be next? What might we do? Where do we go from here? So we've been thinking about that, and here are a few thoughts. The framework could be operationalized for monitoring and reporting. It enables planners and decision makers to assess the dynamic baseline, to track progress, and evaluate efficacy of policies and actions taken on the ground. Another, we could design the framework to be able to generate outputs for different management scenarios, embedded in a framework and maybe an interface that enables users to select from a range of typical treatments to biomass or biomass yields, for example, and maybe with a graphical display that compares various scenarios to a baseline. Another is to incorporate future disturbance risks that take into account the probability of biomass loss from things like harvesting, wildfires, and other disturbances that we measure. You'll see a flavor of that in some of our work for the avoided forest conversion tool that you hopefully will hear about shortly. And also the NFCMS data could be embedded in a range of other tools and platforms used to report forest carbon and to assess climate resilience. And lastly, I just wanted to demonstrate how our data set is different from other things that are out there. The NFCMS is pretty unique in its national coverage, having wall-to-wall data set, being trained on a stratified sampling of FIA yield curves. Its data outputs at a spatial resolution that reach the scale of management units and land ownership. For example, noting that a 30-meter resolution of the NFCMS is about 1,000 times higher resolution than, say, 1 kilometer grid, or more than 10 times higher than a 1 hectare data set. It's also fairly unique in its explicit incorporation of disturbance history and the associated carbon legacies of that disturbance. And then its inclusion of all forest carbon pools spanning live, dead, and soil component, various soil components. And then also by offering a kind of a forecast mode that makes a prediction or a projection, granted it's a grow-only scenario in the absence of severe disturbance, but to characterize the carbon sequestration potential we could expect or hope to have on our forest lands in the future. So thank you for giving me the chance to explain some of the utility of this new update, and I'll be happy to answer questions as we go along.
Well, we have a good number of questions, Chris, and this audience is definitely keeping us on our toes. And what I'm going to do here is focus on questions that are more kind of clarifications, and then save some of the meatier questions for our ending conversation, sort of with all our speakers. But let's go ahead and Joe, I think if you start with CO2e versus carbon, I think that'd be helpful to speak as well as your written response.
Yeah, I wrote an answer in the chat on this, but basically when forest is converted, it's burned or decomposed, it ends up in the atmosphere as CO2. And so you take that atom of carbon and you add couple atoms of oxygen and it's heavier. And so it's just a question of units. If you want to talk about how much the carbon weighs when it's in the tree, or if you want to talk about how much that same carbon weighs when it's in the atmosphere as CO2. And you can do it either way and they're equivalent. But when people talk about carbon credits, when they talk about emissions, they always talk about it in terms of CO2. And so just we thought it would be most useful to present them in units of CO2 because it would allow people to compare to emissions or carbon credits. So I hope that answers the question. And if not, please put a follow-up in the Q&A. Thanks.
Thanks, Joe. And Chris, a couple questions about the plans to update this data and the frequency that it might get updated.
That's a great question. Well, we would love to be in a position to provide updates, regular updates. We're talking with partners about what that could look like and what's required to do so. On our end, it's partly a question of when you try to operationalize something and continually provide updates, you need sort of a processing stream. And we have now built a big innovation from our first generation to where we are now that make it easier to do the next set of updates. So the magnitude of work that went into providing this one was bigger than the next series of updates. But it's also true that we need to turn some cranks to generate the new data sets. We also sometimes need to swap in new data sets because one data set that we rely on becomes sunset, and then we need to switch to a new data set. And we think that might be happening with land cover, one of the key land cover data sets. We have plans for how to address that. It's not nearly as complicated as what we've just done in this new iteration. And again, we hope to be in a position to provide those updates as people see a demand and a need. At the same time, we would say, truth in advertising, and in all honesty, some of what you may not need it every year. I mean, you be the judge, but a lot of the information content about the carbon stock, for example, in 2025 is pretty well told from the carbon stock in 2020 plus a little bit. And so, depending on your application, you might already have what you need. So we could talk more about that. We're happy to explore that with people, but it's always also possible to then make your own subtle modification if you're capable with GIS and know how to integrate data layers to take our carbon data set and maybe mask out forests that have seen conversion according to a land cover data set that you rely upon. So there are different ways to go, and we're flexible and eager to support as we can.
Just so you know how much of an honest broker Chris is, I had to kind of convince him to do this data update. So, when you're working in certain states and there's a lot of harvesting going on, it does change quickly. So I wanted to address one question about the forest legacy assumptions. I think it's a really important point. There is no assumption that all those forest legacy projects would be developed. And so there's a really important difference between whether or not we're suggesting that this carbon that's stored is going to be emitted, or we're just saying this carbon is protected. And so those are two very different communications to make. And I actually recommend communicating both, meaning this amount of carbon is protected and this amount of carbon is expected to be emitted. And actually, Joe and Dan are going to talk to us about upcoming tools to make that more possible, that second piece of the equation, how much carbon is expected to be emitted. And there are so many issues with that we can talk more about maybe in the discussion, but it's a very good and important question. I'm going to take one more question and then turn it over to Joe and Dan because we'll save the rest of these for later. But I wanted to make sure we clarified this piece about ecosystem services. I think it's another critical issue is that we're not just looking at the carbon. Certainly, if you were just thinking about carbon, you might put up solar panels. And so we always do need to be thinking about all those co-benefits to our forests. And Kelly and Taj, both of their organizations have done some great work on ecosystem service, and just wanted to give you a chance to mention those pieces.
Sure. Yeah, I can chime in briefly, and then Kelly. Trust Public Land, yeah, so it depends on sort of what level of detail you want to get to. So we have a conservation economics team that works to do sort of in-depth analysis to quantify the ecosystem services that are being provided by a park system, whether it's an urban park system or a rural park system or a set of conserved lands, and quantify all of the different benefits from health, water quality, stormwater. So you can do sort of those in-depth analyses. There was a report that we recently published that talks sort of more generally about the broad multiple benefits of land conservation work and sort of general messaging around the health benefits of the protected lands, water benefits, climate benefits, air pollution benefits. So there's a wide range of resources. The last one I would just mention is the iTree suite. If you're looking to quantify ecosystem services specifically around your your tree canopy, they have a great set of tools that can quantify everything from water intercepted, air pollution removed, carbon benefits. So that's a really useful set of tools that's publicly available from the U.S. Forest Service. Kelly?
Yeah, I'll just mention we developed a tool that looks at ecosystem services valuations kind of at a very high level. It's a meta-analysis, so to speak, of kind of all the research across the country, and it's a spreadsheet based tool where you can insert information about a particular parcel and the type of habitat, the acreage, and the state, and it generates evaluation kind of based on the research. Again, very high level, not an appraisal, across 11 different ecosystem services. I will say it is just available for Land Trust Alliance members, but we welcome everyone to join the Land Trust Alliance. We're having a webinar next week actually on the tool and how to use it, which is free. And so I can put a link in somewhere, and people can check it out.
Great, thanks so much. There was also a request to see your slide 7. Chris, if we have a moment for that later, we can pull it up, but I'm going to turn it over to Taj and Kelly, or sorry, to Joe and Dan.
Fantastic. I'm here to help answer questions. And Dan, if you want to bring up your slides, we are working on a tool that will share some of this information to help identify places that are at risk of deforestation and how much carbon they would emit if they were deforested. And we think this is a exciting opportunity to share this information in a accessible and useful format. And we're looking forward to getting your feedback on how to make it even more useful. And with that, I'll turn it over to Dan. Dan, you're on mute.
Unmute, look at that. Okay, is that better?
That is better.
Yeah, when I move all of the videos to the other side and I can only see the screen I'm sharing, it messes me up every time. Okay, I'm Dan Micah. I work for TNC under Joe, and I'm the developer on this application. And so it's what we're developing is a web app to, in part, help Chris's data kind of come alive and combine it with multiple data sets to help users understand and make good decisions about potential avoided deforestation projects. And kind of grouped the data into 3 categories of data. Opportunity, which includes carbon benefit, being able to measure how much unprotected forests a given area might have, land cost, and then programmatic opportunities. So, is this area within a forest legacy area? Or if there are other programs that are identified that somebody that we'd want to include, we could include that. Co-benefits, like does a given area intersect with critical habitat? And if so, what species? Resilient and connected lands, water provisioning, and then conversion risk based on past trends of deforestation and future projections of land conversions. So I guess just a couple caveats. What I'm showing here is all still in flux. It's all being developed. Don't read anything into the numbers or a lot of the labels, because sometimes I just make things up for myself while I'm working through this. So it's a work in progress. And if you see fake Latin, it's because it's fake Latin. And don't try to calculate, like, how do these numbers add up? Because they probably don't. It's just kind of me making stuff in my UI mockups to try to work through these things. But kind of the core idea here is it's a mapping-based web application where we're providing data summaries across about 20 different variables at both the Huck 12 watershed scale and the county scale. If there's interest, we could do things like roll data up by states. If there's an interest in sort of dashboard-based reporting to say, here's all of the opportunity in the state. But right now I've got data summarized by county and Huck 12. The different data sets that we've been looking at, I think they're broadly useful for prioritizing forest protection. I've also looked at how Forest Legacy Program scores projects to try to look for areas of alignment, but it's by no means tied to Forest Legacy. It's just that was a good place to look for understanding how people are kind of scoring the importance of potential forest protection programs. Also looked at other resources as I could to identify. So like when it comes to carbon reporting, to understand how different crediting agencies, standards bodies are sort of talking about this stuff. But all of that is more just to sort of help think about how to build an app that works for lots of different people. And so when it comes to the opportunity section of this, some of the things we can provide are a measure of how much private forest carbon is in an area. And all the stuff I'm talking about as far as forest carbon, I've masked out the data, so it's just focusing on unprotected forest carbon. And so because the goal is sort of future forest protection, we could, if there was interest in also showing it on public lands, we could do that. It kind of really changes the patterns and what you see in the data if you do include that. So, but right now it's just showing essentially private forest carbon, unprotected. And so we have this, which comes right from Chris's data, as well as a measure of how many acres in a given area of private forest we'd have. A way of trying to do sort of a back of the envelope calculation of potential avoided conversion, in what that calculates to with carbon. And this just gets at what Abby was talking about, the distinction between sort of protecting carbon versus avoiding the conversion of it. And so we're attempting to do kind of both. And this would allow a user, so this would fill in, we're calculating based on the past 30 years of forest conversion at probably a county scale, the conversion rate per decade. So we can say, if you look in the metro around Atlanta, it might have a much higher conversion rate than someplace else that's, kind of in the stick somewhere. And so we would use this as sort of a default per county that could help inform a number to use as a starting point with a whole lot of caveats on how to think about this. But a user could also change that if they have reason to believe that there's maybe greater or less risk for a given area. Comes to co-benefits, a couple of things we're looking at include resilient connected lands, which is a data set TNC developed to sort of score how resilient a given area might be to future climate change, estimating for areas if they happen to intersect critical habitat, what T&E species might be included in there, and an estimate of the acreage of T&E critical habitat within those. Water provisioning pulled from the Forest Service's Forest to Faucet data set. With all of these, I'm kind of thinking about these different sections modularly, where we can improve them over time. If somebody identifies, oh, it'd be really important to have this metric that I'm missing in here in the app, we could look at incorporating that if there's an easy way to summarize it to make it useful. Um, and then threats. And so, and including both an estimate of past conversion as well as putting together data sets that have tried to estimate potential future conversion, as well as summarizing sort of the current ownership protection regime of a given area. There's a projecting future development is really tough. There's been a number of different studies which try to do it. I'm sure they're all wrong in different ways. And so I think it's just trying to be transparent about that, but also present them as different things a user can see to understand, what does this mean and what could it mean for the future if I'm thinking about forest protection. I should say with all of these layers too, there'll be an option to either show them on the map over here or click, a button next to the layer to be able to show it on the map. Okay, another part of this is being able to filter the data to find unique combinations of criteria. And so you might ask, show me all of the Huck 12 watersheds in Kentucky and Tennessee, which maybe are in the top half for private forest carbon opportunity, have high resilience, have are threatened, have a higher than average threat level, and have been identified within forest legacy areas. So all of this is this stuff I just showed is sort of dealing with sort of pre-calculated areas. And to start, like I said, counties and Huck 12 watersheds. The other part is being able to sort of do custom analysis. And so being able to either draw an area or drag and drop a shapefile and being able to kind of get an instant summary of all of those variables I just talked about for different polygons. And so, one question I would have maybe for discussion is it useful? Would it be useful for people to be able to analyze multiple areas or just one area? It kind of changes how I do the complexity of what I do. But right now I'm thinking about allowing the summary of multiple areas. So that way you can kind of, if you have a portfolio of possible sites that you're looking at, you can evaluate trade-offs between them. But so this would estimate these areas using all the data I just talked about, allow you to export the results as a table, as a CSV, and then possibly at some point being able to select from other pre-existing areas that we provide that we're not going to summarize up front. And so that could be something like eventually it'd be great to get parcel data. There's some complexities and a fair bit of cost in doing that, but that's one potential. You could do lots of other fun things like other watershed sizes, congressional districts, other units that somebody might want to summarize, but they don't want to hunt down the data. If we have that in a standardized fashion, we could think about including that as something where you say, click, let me see parcels, and then you see parcels, and then you click, and then it analyzes for that suite of metrics. Okay, to summarize, summarizing it at a couple different scales out of the gate, providing custom analysis and being able to filter this data. We're shooting for a beta release in January that people could test and we can get feedback on. I've got some questions when we get to the discussion section that I would love to hear a little bit more about if people are interested in this tool and, what we could do to make the tool better. And if some of these things are useful, but I'll stop sharing for now and shut up.
Thank you, Dan. And you all are getting this information real time. And there was already a question about how the tool can be accessed. So not yet, but coming to theater soon. And there is this opportunity to engage, and we could set up a separate, webinar to even have some interaction and conversation and live beta testing of that tool if we wanted. But people can indicate if they're really interested to engage in that kind of early phase in the chat, and put that in the chat, not in the question section, and we can see how many folks we can work with on that. I wanted to just ask one question related to something you mentioned, Dan, about public and private land. So the question was phrased as, do your measurements differentiate between public and private forest land? And I think you could interpret that various ways, but I wanted to just ask you to go back to what you had shared about sort of which ones you're analyzing.
Sure. So right now I've masked out public lands. And I went back and forth on thinking about what's protected and what's not. Like I didn't, my goal thinking about, my goal was thinking about future forest protection, but not trying to get overly perfect about like gap statuses and this and that. So basically what I did was using Pad US, I assuming
Protected
lands
area database. Yeah.
assuming that lands are under some form of governmental control, local, state, federal, whatever, or private conservation. I mask those areas out, with the exception of state trust lands, because state trust lands can still be developed under some circumstances. And it depends on the state and how they deal with their state trust lands. But I included them as within the data set because it felt like there was still potential for conservation to happen on those and smarter planning maybe. And so I didn't want to totally wipe those out when showing data. But I did, like if you look at the map, including Forest Service lands and not including Forest Service lands, it paints a totally different picture of what you need to worry about if you're interested in doing forest protection.
I think it's really helpful. And then I want to emphasize too that at Open Space Institute, we have focused on the forest carbon in protected lands, and looked at the difference between the levels of forest carbon storage in protected versus private lands to sort of understand the benefits of land protection. There was a significant higher value of carbon on certain protected lands than certain private lands. So that's just another way to look at it, right? Both are important, and the data covers everything, and you can screen one for one or another. I'm going to turn it over to Kelly and Taj to talk about the support and how to access the data, and also find additional support for its use. And then we'll have, I think, a really robust conversation with some of the other great questions that have been asked.
Sounds good. Thanks, Abby. I'll get things started. So, hey, everyone, I'm Taj Shotland. I'm the Associate Director of the Trust for Public Lands Climate Program, based in Vermont, but I get to work nationally. And I've been working with this partnership now quite a while. We've been together working on these data updates for 2 or 3 years. And we call ourselves sort of the Forest Carbon Data Partnership, but I will say the focus isn't just on the data and the science. You can see this slide here, right? We're really focused on putting it all together. And so it starts with the incredible science that Chris and Joe and others are working on, then the development of these data sets, and then feeding them into tools so that you all can make sense and make use of this science and this data, put it into action, and that's when you start to see the impact. So we call ourselves Forest Carbon Data Partnership, but really we're committed to that sort of full cycle of putting the science into use and helping you all have an impact on the ground. So the next few slides, we wanted to just sort of put everything together, synthesize what you've heard, and then help folks start using the data right now. So what's available right now? So the 2020 forest carbon stock data set is available. That's, as Chris had mentioned, a CO2 per acre. That's available. The 2020 to 2050 annual carbon sequestration data is available, and I'll talk more about how to access these. And they're available right now through ArcGIS Online. What's coming, you heard this sort of the mock-up of this avoided conversion tool. So coming in early 2025 is that new avoided conversion tool. There's going to be an update to the Resilient Lands Mapping Decision Support tool from the Nature Conservancy. If folks aren't familiar with that tool, it's a fantastic tool. Most or all of our land protection staff at the Trust for Public Land use that tool to quantify the carbon that are on landscapes that we're conserving. Really powerful tool. That's going to be updated in 2025, early 2025. And then we're also going to be making these data available through the U.S. Forest Service. So how do you get the data right now? So it's on ArcGIS Online. And as Chris had mentioned, that covers total carbon in forested landscapes. So it's above ground, below ground, total forest carbon. The volumes, as Joe and Chris mentioned, it's CO2 per acre to help with that analysis, that sort of comparison to what generally folks are using in emissions calculations, GHG accounting. It's 30-meter data resolution. And it's available for viewing on ArcGIS Online. So that's a map viewer. If you have a GIS team on your staff, they'll know exactly how to get to this data and download it and view it. If you don't have GIS folks, but you have some GIS knowledge, I think it's about $100 or so to get a license. I think Abby was mentioning it was about $100 to get a license for a nonprofit to go in, create an account, be able to access these data. And one of the powerful ways of viewing this data on ArcGIS Online, you can pull in other data sets. So I think there were questions about looking at public lands versus private lands. So you can pull those data layers in. You could pull in air pollution to overlay with existing carbon data sets. So there's lots of ways to analyze the data. It's available there on ArcGIS Online to both view it and then also download it and analyze it. There's also that sequestration data that's available. So that is looking at annual sequestration from 2020 to 2050, the average annualized amount of carbon that's being pulled out of the atmosphere. Again, same level of detail, 30-meter resolution. It's in CO2 per acre annually. And you can see here, I included these two screenshots in particular because you can see nationally, here's what the sequestration data looks like. And then I pulled this screenshot from the Denver area where you can see it shows the forest carbon annual sequestration in the forested landscapes. And then when you look a little bit to the east, you don't see carbon showing up there. That's not to say that there is no carbon in that landscape. It's just that there are not trees, right? So it's grassland. So I wanted to just highlight that to reiterate that these data are showing forest carbon, but there is still lots of other carbon in grasslands, in coastal wetlands, but that's not the focus of these data. I'll note, so we put these data online on ArcGIS Online. We've also nominated them to be part of what's called Esri's Living Atlas of the World. So that's really the premier collection of what are deemed authoritative GIS data layers that basically serve as a go-to sort of one-stop shop for GIS professionals for environmental data layers. And so Esri, we've developed other data sets that have been posted that have gotten accepted into Esri's Living Atlas. It should go in within the next few days or a couple weeks. And once it's on the Living Atlas, we're going to hope to see a large number of folks going in and using. There were some other data sets that we've published on Esri's Living Atlas that have gotten 500,000 views and downloads. So the hope is we can exceed that with this data layer. It's going to be of a lot of interest to a lot of folks. And so it'll be there highlighted on Esri's Living Atlas that any GIS professional can go in and view and download. And just on that point, I do want to give a shout out to our GIS team, Dale Watt, and our web manager, Dave Hines, who are working. They were scrambling over the last couple of weeks to get these data up onto the ArcGIS Online in time for this webinar, and they succeeded. So thank you guys. And the data is there and available, and we're going to be posting links to be able to access that data in the chat and in the follow-up. So that's how you access the data right now, and I'll turn it over to Kelly to talk through some use cases and next steps.
Thanks, Taj. Were you going to go over the project evaluation, or was I?
I was not, but I can if you want me to.
Perfect. Why don't you take it and I'll fill in anything?
Sure. Yeah. So this is just showing, this is a screenshot from the Resilient Lands mapping tool that's going to be updated in early 2025 that allows you to go in, either upload a shape file or look at just sort of a large regional scale, the carbon storage and sequestration metrics. And there's even a sort of a little what's like speed dial that sort of shows, is it a moderate high, very high amount of carbon on that parcel on a per acre basis. So it's a really good way to do sort of an apples to apples comparison if you have multiple parcels that you're considering for conservation, which one actually has the most carbon per acre and represents potentially the biggest bang for your buck in a conservation project. So that's the TNC Resilient Lands mapping tool. Hopefully most folks are already familiar with it, but if you're not, go check it out, and it'll have the new data in early 2025. Oh, there's the, I
Yeah,
should
there's
advance it. There's the speed dials.
there's the speed delta. And I'll just add, OSI put together this really great guide, just kind of a one pager on how to compare parcels using the Resilient Lands Mapper and kind of comparing averages. And I think it's either included in our resources, or Abby, maybe we can make sure to add that to the list. Great. Thanks, Taj. For those of you who don't know me, my name is Kelly Watkinson. I'm the director of the Land Trust Alliance's Land and Climate Program. Just want to thank you all for your interest and for sticking with us for this long. For a number of years now, I've had the opportunity to collaborate with Abby and her team to offer the Land and Climate Planning grant program. This is a program that helps conservation organizations bring climate science as well as communications into their conservation planning efforts. And just want to highlight that over the past 4 years, we've invested over 1.4 million and supported 111 conservation planning and communication projects that cover 31 states plus Puerto Rico. We've also worked with Trust for Public Land, Nature Conservancy, and all the partners of our partnership and beyond to offer numerous trainings and resources. And we'll continue to do that with this new data. Next slide. So through our collaboration, we're really hoping to help change the way conservation happens on the ground. I think everyone has mentioned that we're all committed to helping the land trust community really understand and utilize the science to advance forest conservation and climate action. The good news is this work is already happening. We're learning and trying to share lessons along the way. Next slide. So one example is in New York, where TNC New York has been working with the New York State Department of Environmental Conservation to create or complete a state forest land assessment utilizing the carbon data. This is allowing them to evaluate their state land holdings, which are shown on this map, as well as help inform their management decisions moving forward. Next slide. And another example is in South Carolina. So with help from Open Space Institute, the South Carolina Conservation Bank has integrated the carbon data into their prioritization planning, specifically for sustainable forestry. And this looks at it from, across the entire state. Next slide. So through the Forest Carbon Data Partnerships combined resources and expertise, we want to continue to support the learning. We're committed to advancing the science, the implementation, as well as the policy work needed to meet the opportunity. And all of you are critical to the success of this work. So we want to hear more about what you need. I think Taj mentioned this as well as Abby. Developing resources is not our goal. Our end goal is to help the conservation community be agents of climate action to the greatest extent possible. We have quite a few resources available now. There's a list here. Some of these are only available in certain geographies. But we also have some new ideas that we're considering as far as developing and providing to the field. But we want to hear from you how we can best support your work and help you utilize these tools. So we have 2 polls that we want to run to get your feedback. And can we launch those polls now? Here we go. Okay, so our first poll is we want to know how you plan to use the data and resources. Do you envision, and you can select your top three, policy and advocacy, conservation targeting, your communications, outreach engagement, making the case for your existing projects, general education, or maybe building it into your strategic planning. And then the second question we have is, with how you're going to use it in mind, what resources would you find most useful to kind of allow you to do that? So select your top two or three there. Things like online trainings, a resource hub where you can kind of find all the information in one place, recorded demos for some self-study, written guidance again for self-study, one-on-one technical assistance, someone to come in and kind of help you walk through using it, troubleshoot. A mailing list just to be kept up to date when there's additional resources or news or opportunities, or maybe a peer cohort where people using the data kind of get together regularly and troubleshoot, share experiences, successes, that kind of thing. And I don't see how votes are coming in. Yeah, so when you think all the votes are in, maybe you can publish the results so we can all see how this.
As Jasmine does that, we can maybe just take another question or start to frame our conversation. And I think some resources have gone into the chat and others are coming. One thing I wanted to flag related to the this guide that Kelly mentioned about 6 simple steps to evaluate contribution of land protection. That resource is based on the old version of the TNC resilience tool. So it has been updated and looks different, but you can still use it the same way and ask the same questions. So it's actually easier to find the forest carbon data now. Jazz, why don't you go ahead and share those results and we can, and then I'll frame some questions for the conversation. Great. So we're seeing that most folks, 65%, are interested in using the tool for conservation targeting. Nearly 50% interested in strategic planning, I guess, for your whole organization. Other uses that seem to be of interest, outreach and engagement, policy advocacy, and then this idea of a resource hub where everything's kind of co-located and you can go to one site to get everything you need. That in our last gathering also was most popular, 70% coming in with that need. And then looks like series of online trainings is number 2. So that's really consistent. It's actually very helpful to hear that those are still of strong interest. And we are working now to set up the funds and the timeline for engaging those pieces. In terms of written guidance, Jasmine just put in the chat this document, Guidance on Use and Application of National Forest Carbon Monitoring Systems. That is a wonderful resource that reviews a lot of what Chris shared in his presentation in some detail for users that want to really understand the data set. So please do grab that. We'll also be sending all these resources out. So if there's not a live link in something, you'll be getting it soon. So let's take some of the remaining of our time to step back and look at some of these good issues that people raised. One theme that I was seeing is this issue of how does this work relate to other natural climate solution pathways, right? People are asking about forest management, and people are asking about planting. And we have Kendall Deiser here from American Forest. She's part of our partnership. She's actually acts largely as a liaison to a lot of the work that's going on in other natural climate solutions. So wanted to give you a chance to talk about that and share any resources, and Joe or others may have comments on that as well.
Sure. Thanks, Abby. This is a lot of great info that's being shared, and I'm really excited, having been part of this partnership for a while, to see the data up on ArcGIS Online and these tools that are coming out. I think there's a lot of need for information, as Abby used the phrase earlier, for carbon defense. If we're thinking about, natural climate solutions or nature-based solutions, half of the battle is just kind of keeping us where we are in terms of the forest carbon that exists. And the data that Chris has put together, the tool that Joe and Dan are building, all of this work is really important to just have a better sense of where that carbon is. I actually really loved, I hadn't seen that map with the overlay of the current forest legacy areas. That seems like one of many possible ways that this can be useful, just to start targeting kind of more holistic plans for state forests or forests across the country. One of the efforts that American Forest has been leading on, which is still early enough in development, we didn't need to throw another kind of proto tool into this webinar, but it's a platform called the Forest Innovation Platform, which is supposed to provide information about the risks of climate change to forests and provide some resources about how adaptation actions that can be taken. Part of that, of course, is getting a sense of what are the values that we currently need or get from forests, including carbon. So having this information about where that carbon currently is really, really important for understanding how much of that is at risk from future climate impacts. We also want to enable that information to the point of some of the poll that Kelly talked about, being able to have a repository of information, being able to enable the conservation community to be good stewards of the land, understanding where that carbon is now, but also understanding how much of it might be at risk from future climate impacts, whether that's just temperatures and precipitation being different, or if that's wildfires maybe getting a little bit more severe. Understanding where those areas are and maybe starting to take some actions to help protect them. If we can be more forward thinking in that way, can really help make a difference in that carbon defense overall. So I think it's really exciting to see some of the stuff start to come together, and think about how we can leverage all of the work that's being done here to really help get a lot more of this work going on the ground.
Anything you wanted to add, Joe, or anyone else, about links to other pathways?
No, I just, one sort of framing is when I think about forests, I think about, 3 different pathways for natural climate solutions: so protection, reforestation, and improved management, or essentially protection, planting trees, or improved management. And this is really focused on that protection or avoided conversion. So we're looking at private lands that are at risk of being converted to another land use, and easements or acquisition can help ensure that the carbon that's currently there, and also that the growth of those trees continues. And so that's what we have been able to quantify. But for if you're planting trees, that there's different science to support the projection and quantification of that climate benefit. And if you're out doing improved forest management and changing the harvest, either by setting aside more of the land or extending the rotation, there's other tools and programs out there to quantify that. So that's something that maybe we could have made a little clearer right up front, but I think that's how this fits.
There's a little background conversation going on in the chat and in the questions about the proliferation of tools, and it's a little confusing. And I think that is a challenge we find ourselves in, with so much capacity to build new tools, right? This is a growing field. There's more and more ability for people to develop tools and more functionality to those. So people are always developing better ones. I wondered if Joe or Dan, if you just want to talk very briefly to the difference between the tool you're developing and the TNC resilience tool, and anything else you want to kind of flag there, but just very high level, major uses, questions you might answer.
I was just typing out a response, but it's probably faster to talk than it is for me to try to listen and type at the same time. So yeah, I think there are a number of tools. I'll throw a couple others while we're at it. There's this app that I worked on for the past 3 years called NatureBase, which is a global tool related to natural climate solutions and measuring across all 20 pathways. There's the Reforestation Hub, which is geared really on towards NCS for just reforestation. So yeah, there's a lot of these different tools. I think when it comes to the Resilient Connected Lands tool, its primary focus is on understanding resilient connected lands. And these other things are sort of like, and there's like a million data layers in it too, but it feel like all the different slices to try to explain RCN. And then there's the carbon stuff that's sort of added in there. And so our goal, I think, with the app that we're building for avoided deforestation is really a little more laser focused on what can help you prioritize across multiple areas and understand the components which might help you do better forest protection for NCS. Whereas, the resilient connected lands, you could use it for a lot of things. You could use it for where resilient, I don't know, grasslands or something. It's not specific to just forests and private forests. And it doesn't look at threats, and it doesn't look at all these. So there's some overlap, but we're also, I think, trying to do different things.
And one difference to think about always is climate adaptation versus climate mitigation. And so the resilience tool is really focused on adapting and how species are going to adapt. And then this is really thinking about how can forests mitigate climate impacts.
Abby, just chiming in briefly on this tool proliferation and understanding the different tools, what they're designed to do. I think that's one of the sort of our top goals when we create this, if and when we create this resource hub, is having a really simple sort of decision-making framework that lays out, here's the universe of tools that are available to you. If you have these questions, go to this one or two tools. If you have this question, go to some other ones. And to be able to have in one place a simple description of each tool, what questions they answer, and how to use them, I think will be incredibly useful. And I think that's maybe reflected. One of the reasons I would guess that the resource hub is mentioned as one of the top priorities. I think that's a growing need for the community of users.
That's perfect, Taj. And the other thing that differentiates a little bit what we're doing from other tools is really focused on this potential for land protection to kind of be a climate solution. And a lot of the other tools are focused on management, which includes kind of replanting as a management activity. So that's really the piece that we're working on and working to advance. Though lots of potential for, I think, some of the work we're doing to interface, as Kendall was saying, with those other pieces and vice versa. So I wanted to go to this important conversation that's already gotten started in the Q&A about cutting as a strategy for carbon sequestration. Another person mentioned in the Q&A they prefer to see management to support sequestration. What does that even mean? And then the value of old growth, right? So I know that there were great responses in the chat from both Joe and Chris. People can look at that. But I wanted to just open it up for a little conversation. I think it's a really important issue that we clarify. Kendall, you may have thoughts on this from the management models you run. Wanted to just open it up. Go ahead, Chris.
Yeah, there are a lot of us who could start to tackle that question. We think about it a lot, and we hear the same question repeatedly from different angles. So good one to think about. I mean, one of the things I come back to is this concept that most management almost all management involves at least a short-term reduction in the carbon stocks of forests. It typically involves some kind of removal of biomass to make space for a different kind of forest, a different tree type. And sometimes it's even just harvesting is suggested as that we can harvest our way to a climate safe future. It's a special niche. It's a narrow window of opportunity to take carbon out of forests and store it long enough for it to last longer than it takes for that same amount of biomass to regrow. That's a pretty rare case. It is possible to store harvested wood products in long-lived use, and for that to pile up, meanwhile, a forest regrows. But that's a really bad bet because it's exceptionally rare. These days, we also hear about things like the wood vault, or a way to lock away, like harvest trees or take wood residues and lock it in the ground maybe, or even sink it to the bottom of the ocean. Those are really niche and small opportunities, and for them to add up to a meaningful wedge, there's a lot to work out there, and it seems pretty unlikely that that's our best strategy. In fact, most scientific studies, probably all that look at this in an honest way, would suggest that leaving forests alone is often our best strategy to enable them, support them with continued growth and sequestration. I would start with that and leave it to others to add. I would flag one other thing, which is where sometimes our forest stocks are highly vulnerable to release to the atmosphere through disturbance. That's another kind of special case where if we know it's about to go up in smoke, some have made the case that maybe better to harvest, use it for the wood products industry, but actually there's a lot of value in even our burned forests and even in the opportunity for them to recover. So I'd be careful with that suggestion. I think in general, the motivations are pretty low from a climate perspective to harvest our way to a cleaner future.
That was a good ending line there, Chris. Joe, Kendall? Yeah, go ahead, Kendall.
Yeah, a couple thoughts to add to that. And Chris, you started to get to this at the end of your comments, that there is a lot of the quote unquote best strategy that depends on where you are and depends on the condition of the forest. So I think what you're urging here is that we don't put all our eggs in any one basket. There are places where trees can continue to grow and they're not really at threat from natural disturbances, and they have a happy and healthy future in front of them. There are places where there are too many trees on the landscape and they are contributing to wildfires that are getting bigger and more severe. And then you have burns that are bad enough that trees can't come back at all. I think that's not really the kind of future that we want for our forests across the country. But the point is that these strategies need to be kind of tailored to the local conditions. We need to have a balance of keeping the carbon that we have in the forest now, but also making sure that we can continue to sequester carbon, or at least not lose ground on where we are at the moment. So I think looking at forests, for example, in the Northeast versus forests in California, you're going to arrive at some very different strategies. And that's part of the work that you mentioned, Abby, that I've been leading for American Forests. We're doing a lot of modeling on what climate smart forestry actually looks like in different places. And the scientist's favorite answer is always that it depends, but it really does in this case. We can't say that you need to cut every tree and that's the best solution. We can't say you can never cut a tree and that's the best solution. We need a balance of these things across the landscape. And really what we all want, I think, is to have a healthy and resilient forest that continues to grow, to capture and store carbon, and provide all the ecosystem services and other things that have been mentioned up to this point.
And I just want to make one distinction between what you're saying and what Chris is saying. What I'm hearing really is that the reason to harvest isn't climate change, but there are many other reasons to harvest, and that's a piece of the equation, absolutely. But I think that the reason to harvest isn't climate change, I think is a helpful distinction. Yeah. Anything you want to add, Joe, or anyone else?
Yeah, I mean, small trees don't sequester as much carbon as bigger trees. So if you look at how much carbon is added, it starts out slow and then it gets bigger and bigger and bigger, and then it reaches a maximum and then it goes down. But it goes down kind of slowly, and they actually there's studies of forests that are 200 years old and they're still sequestering some carbon. So so it's not true that just cutting it down makes for more carbon storage. There's it depends on what happens to the trees that you cut down. I guess if you're using them to build houses, then that's carbon is stored for a relatively long time in those long-lived products. If it's going to paper or something, then that goes back to the atmosphere pretty quickly. So it's complicated, but our mature forests are doing a great job of storing carbon, and in general, keeping them intact is the best thing for the climate.
And I'll just mention that Joe's colleague, Mark Anderson, has done some interesting work just looking at the research on carbon sequestration in old forests, and also very interesting stuff there. So if you want to look up his work, I think he's terms it wild carbon. And I just wanted someone actually to talk a little bit about emissions in newly planted forests. Just because it's come up in a number of conversations that I've had, and just to understand sort of that in the very early years of planting, that there are some emissions from the trees as well.
Yeah, so I think I know what you're getting at. I mean, if you look at the stand scale carbon balance in areas that have seen recent cuts, you might remove some of the wood and take it off site, and that part's not being emitted promptly in the forest, but might be emitted somewhere else, right? Like at a mill, some of its residues, and it burns other short-lived wood products. But also even in the forest, in our young forests that have seen recent clearing, you'll have below ground carbon stocks, some of which decompose and are emitted to the atmosphere. And that can lead to net carbon release in that tract of land for some years, sometimes even decades following that forest disturbance. Abby, is that what you were getting at?
Yeah, exactly. It's just the respiration is so high in those early years that the net balance is towards emissions for early forests. So it's just another consideration that has to go into the picture.
Yeah, it's one sector, one part of what's sometimes called the carbon debt of the disturbance action on the land.
So there's some good shorter questions here. I love that this is our first question on forest carbon markets. We've struggled to differentiate this work from the carbon markets at times, and but it's an important thing to talk about and how it relates. So the question is with the closure of mills, do you see carbon market mechanisms filling that space? It's kind of an economic question. I don't know if anybody wants to answer that specifically, or even just talk about sort of the intersection of some of our work with carbon markets.
I could chime in one kind of random comment about that. And I just know enough to be dangerous. But, when thinking about additionality, I do know that a lot of the forest protocols, especially improved forest management, they look at the existence of mills and the ability to actually harvest in a particular region. So if all the mills are closing in an area and a forest doesn't really have a reasonable ability to be harvested and brought to a mill, then in a lot of cases that wouldn't be considered additional carbon. Because anyway, I'll leave it there. So it wouldn't necessarily pick up all that slack or all that economic value that's being lost from a mill closing.
Yeah. And I'll mention just that, one of the ways we think about the carbon markets is also as a financing mechanism for conservation where appropriate. Plenty of issues with how the carbon markets and conservation have intersected in the past. a topic of a different webinar. But there's certainly efforts to really address high integrity forest carbon credits. Anything else anybody wants to add on that one? There was a question here about the tax incentives and that a lot of these kind of tax incentives for forest ownership require harvests. And this is something we see across a lot of states. One model I wanted to share is that Vermont has successfully shifted their current use, that's what these programs are often called, current use tax incentive, so that you can have sequestration as a public benefit, and that the harvests are not required to obtain that benefit. So that's a model people can look to as an example. It's something that's live conversation in a lot of other states as well. And I think it's a really important kind of parallel conversation to the permanent conservations. These are sort of perpetual or longer term conservation strategies that are also really important. Anybody else want to comment on current use? All right. I think we can begin to wrap up. I really appreciate the engagement of the additional 80 or so of you who have stuck with us to the very end. I want to thank first of all, I want to thank all of these partners. It is such a pleasure to work with each and every one of these folks. And it's really powerful to sort of see the way that the different expertise can come together and support the field. So we're excited to continue to stay in touch with all of you. I also really want to thank our funders, Jane's Trust Foundation, U.S. Forest Service Forest Legacy Program, RBC for Nature, all supported the data update, and many other funders going in to support each of these organizations and their work. We will be in touch with follow-up materials, the presentation slides, the Q&A, and the resources that were shared, including the more technical resources that Chris posted in the Q&A. And then we will be in touch as we make progress. So we have everyone's emails that registered, and we will be able to follow up with folks and keep you updated on our progress. So thank you all very much. And yeah, keep up the good work. It's it's really important.